Neha. I am explaining ATC assignment, designing and implementation of lexical analyzer and purger of mini ATC language using Python. First is introduction. Automata theory is a foundation of a compiler designing and programming language processing. Every programming language requires a translator to convert a source code into a machine understanding. For the first stage of this process is lexical analyzers and the syntax analyzers are the two analyzers we use. And In this, we check whether the token sequence follows the grammar rules or languages using context free grammar. In this assignment, a simple language called mini ATC is used to implement both lexical analyze and posture using Python. Second is objectives. Objectives to identify the tokens of mini ATC language and to design the finite automata for token recognition and to apply the context free grammar for syntax checking to implement lexical analyzer and posture to validate the correct and incorrect program. Next is mini ATC language specification. The program structure where begins the statement list and also it is a middle statement list and the statements first. Here the mini ATC language specifies the structure and also statements. Next is lexical elements and justification. Here, the justification token types are included keywords, identifiers, numbers, and operation. These are the tokens type. Example like for the keyword begin, end, and int, print. These are the examples. Identifiers x and some one total two. Numbers is 10, 25, 100,000 like. Operation plus, minus, into, and slash where justification of the keyword is receive the word with fixed meaning and variable names defined by the users for identifiers. The numbers these are the integers context and operation program operations like we use. These are the elements and we justification. Fifth one, lexical rules like rules must begin with a letter. Like the it will be beginning with letter may contain letter and digits. The where the valid are x total one sum two and invalid are x a b minus c. Negative integers are not allowed in the rules. The number rule one or more digits only non-negative integers are allowed. These are the rules. And next, finite automata design. DFA for identifier recognition. This is a DFA where Q1 is a accepting state, Q0 is a start state. Here, final state is also a Q1. The Q4 is a trap state. The expression like the start at Q0. If the first character is a letter, it moves to the Q1 and continue reading letter digits in a Q1. And in the Q1 means valid identifiers. AFA for number recognition. It it is also one of the example for uh, Q naught is a start state, Q1 is a final state. Here the digits read first digits. It continues digits in a Q2 and in the Q2 it means the valid number. And next is uh, context free grammar. In context free grammar we can see like program and stmt list stmt and assignment print stmt and team factors. These are the context free grammars. CFG means context free grammar is suitable. It supports the expression like x plus 5 into z. It will support the expressions like etc x plus 5 into z and etc. Defines the syntax clearly and help the further validity structure and supports the operation and predict. Example, here we have the priority, then plus and minus. These are the examples. And pairing parser logic. Here the program, these are the logics and rules of this uh, parser logic. Here stmt list and stmt, these are the etc team and factors, these are the rules. Each functions represent one of the grammar rules. Algorithm, lexical analyzers. First, it will read the input of the program and ignore the space and identify the tokens and store the tokens list. Next is parser. Parser state from the program matches the begin and parser statement match the end if it will be successful and it is a valid syntax. This is a code implementation of the Python. Here the we use Python like we can see here the code will explains like overall lexical analyzer and parser converts the source code into a tokens and checks whether the token follows the grammar rules. Lexical analyzers means here the token users like keywords, identifiers, numbers, operation we can use, and we use the Python laser function reads the source program and identifies the tokens. It explains the pattern and identifies. Token identification, if the word is keyword, stores it means if the word is keyword and stored it as a keyword word. Stored operations like we can see plus and minus in this code. It will check if the token is number and stores the variable names and check whether the program follows grammar rules. And the program must starts with begin and contains statement end with a end. And program starts with begin, it will program end with end and matches like check, it will check the whether correct tokens matches the expected tokens or not. If it will be if it will not matches means it will raise the syntax error. Like that the code will be explained. And final output is uh, program follows all CFG rules and no syntax error found, and purser accepted the program. Like final output is program is grammatical correct and missing semicolon. It means the overall it will be a correct output of this code. So overall conclusion of this assignment is lexical analyzer identify the tokens and Porsche validates the syntax using CFG. And here the program is successfully detected valid and invalid meaning ATC program. So the conclusion is the assignment is successfully demonstrate practical application of automata theory. Finite automata where they used for token recognition and CFG and using syntax analyzer and Python implementation correctly checks whether the mini ATC program is grammatically valid or not valid. Thank you.